Hello everyone. Today we are tackling Leetcode problem number 1351, count negative numbers in a sorted matrix. So first let us understand what the problem is asking. We are given a grid which is just a matrix of size n cross m. And our task is very straightforward. We have to count how many negative numbers exist in the grid. However, there is an important twist. Each grid is already sorted. Specifically, it is sorted in the non-increasing order. So, what it means is it is sorted in a descending order. So, this means any row numbers go from larger to small as you move from right, and in any column number go from large to small as you move downwards. So because of the sorting, all the positive numbers tend to cluster on the top left corner, whereas the negative numbers are concentrated in a bottom right corner. For example, let's take the example matrix that has been given. So let me first write down the matrix 4, 3, 2, minus 1, 3, 2, 1, minus 1, 1, 1, minus 1, minus 2, minus 1, minus 1, minus 2, minus 3. So if we take a look at this matrix, all the negative numbers are clustered in the lower part of the matrix, while all the positive numbers are clustered in the upper triangle of the matrix, right? So we include this also here. So the first logical approach is to solve this question by using the binary search problem. So what is a binary search algorithm? So let's take an example of a word that you're looking up in a dictionary. So you don't go page by page looking for a word that starts with the letter M. So let's take the word magic. So you just open the book like in the middle and see if you have crossed M in the alphabet or you are before M in the alphabet. So essentially you just separate the entire dictionary into two, and then again if it is not the element that you have been looking for, you either look towards the right or the left. Same we apply in the binary search algorithm. But if we use binary search to solve this particular question, the time complexity will be big O of n. I will introduce another optimized solution in which we can solve the entire question in O of m plus n time. So let's get started. So here's the trick. We start at the bottom left corner of the matrix. From this position, moving up takes us to larger numbers and moving right takes us to smaller numbers. This gives us two clear directions to move based on what value we see. If the number we are standing on is negative, that's great news because the row is sorted in descending order. Every number to the right of this position must also be negative. So we can count all of them at once and then move up one row. If the number is positive, we know we need smaller value to find negative, so we move right. We repeat this process until we go out of bounds. The code for this optimal approach is actually shorter than the binary search version. So we start with the row index at the last row and the column index is at the first column. While we are inside the grid, we check the current value. If it is negative, we add n minus to the column index to the count that represent all the remaining cells in the row, and then we move up. If the value is 0 or positive, we move to right. The pointer moves like a staircase along the boundary between positive and negative numbers. So now let's talk about the edge cases. If the grid is entirely negative, the pointer starts at the bottom left, counts the full row and keeps moving up until it reaches the top. If the grid is entirely positive, the pointer keeps moving right until it exits the matrix, resulting in a count of 0. This logic works for all matrix shapes, including single rows and single columns. Here the integer row stores the number of rows in the grid, and grid.length gives the total rows used to know the vertical size of the matrix. And int calls give the number of columns, and grid of 0 dot length is the length of the first row, which is the number of columns n. And we start the pointer at the last row, so bottom left corner of the matrix. Using the bottom left is strategic. Moving up, values increase; moving right, values decrease. These directions align with the sorted property of the matrix. So when we initialize call to 0, it starts the column pointer at 0, that is the first column leftmost. So row comma column initially points to the bottom left cell, and while we initialize int count to 0, it initializes the counter for negative numbers. So the conditions for the while loop that we are initializing here is the loop continues as long as we are inside the grid. That is, if row is greater than or equal to 0 and call is lesser than columns, that is, we haven't moved past the rightmost column. So it ensures we don't go out of bounds while traversing. The if statement checks if the current cell is negative, because the rows are sorted in descending order, and if the cell is negative, all cells to the right of this row are also negative. And then the count value gets updated. If the if statement is not satisfied, we move up a column, and then finally we return the count. So that's all for today. Hope you enjoyed this video. See you later.